session, we'll be solving numericals for a circular and a triangular section. So for this circular and a triangular section, we'll be finding shear stress distribution diagram. Now let us see what formula we'll have to use in order to find a shear stress distribution diagram for a circular section. So as you can see, this is a circular section here, and to find maximum shear stress, the formula is, you don't have to see all this derivation here. You directly see here, which is shear stress Q max will be equal to 4 by 3 Q average. So this is the formula that you will have to find in order to find Q max. Okay, and to find this average shear stress, now 4 by 3 Q average, to find this average shear stress, it will be force by area here, right? And this force by area will be equal to area of the circular section will be pi by 4 d square. So you will have at the end this one, force by area. Okay, you will have force by area, and area of the circular section will be equal to pi by 4 d square. Okay, you don't have to worry about all this derivation here. You need to know that maximum shear stress for this circular section will lie at the neutral axis. Okay, right at the neutral axis, this line, the maximum shear stress will lie here. So here, okay, and the average shear stress will be around this point somewhere here. Okay, so let us start with the first numerical. So the first numerical says a circular section of 100 mm diameter is subjected to a shear force of 3 kN when used as a beam. Determine the maximum shear stress induced and the minimum shear stress. Sketch the stress distribution diagram. Now from this given statement, we first need to jot down the given from this question, the data is given, and then let's see how we can solve and find shear stress distribution diagram for this circular section. For this numerical, a circular section of diameter. Now let us first write down the given from the question. So given we have diameter of a circular section d equals to 100 mm, and it is subjected to a shear force S. Shear force S equals to 3 kilonewton, which if we convert it into Newton, it will be 3 into 10 raised to power 3 Newton. And we have to determine the maximum shear stress. We need to determine maximum shear stress, which is Q max, and minimum shear stress. Minimum shear then we have to sketch the stress distribution diagram. Now for a circular section, neutral axis will pass along this line. Alright, so this is the neutral axis point and this will be the centroid. Now for this Q max, which is maximum shear stress, Q max will be equal to 4 by 3 Q average. This is the formula. Okay, now Let us start by finding the Q average. Q average will be equal to Q max is equal to 4 by 3. Q average is equals to S by S, shear force by area. Now from here what do we get? 4 by 3 into, how much is shear force given? It is given 3 into 10 raised to power 3. 3 into 10 raised to power 3 Newton divided by, the area of the circle will be pi by 4 d square. Area will be pi by 4 d square, right? So how much is d? Diameter is given 100 mm. So let me directly put here pi by 4 into 100 square. So from here, maximum shear stress will be coming equal to 0.509 Newton per mm square. So this is the maximum shear stress. Now next we have to find Q minimum, right? For a circular section, Q minimum will be 0. Okay, Q minimum will be equal to 0. So we don't need to find, it will be 0. Okay, so let us draw the shear stress distribution diagram. Right, it will be maximum here and then come to minimum. So this is the place where you have maximum shear stress. Q max is equal to 0.509 Newton per mm square. Now this is a shear stress distribution diagram for a circular section. So I hope this numerical is clear. Now for the second numerical, it says a circular section of diameter 150 mm is subjected to a shear force 100 kN when used as a beam. Calculate the average and maximum shear stress and draw shear stress distribution diagram. Now again in this case it is a circular section. जैसे हमने क्वेश्चन नंबर 1 पे सॉल्व किया है, ये भी वैसे ही सॉल्व करना पड़ेगा. Okay, so let us get started. For this numerical, again a circular section is given and the diameter of this circular section given is d equals to 150 mm, and again it is subjected to a shear force. Shear force S equals to 10 kilonewton, which will be 10 into 10 raised to power 3 Newton, right? Then we need to calculate average shear stress. Average shear stress, which is Q A V G. Then next we need to find maximum shear stress. Shear stress, which is Q max, and then draw the shear stress distribution diagram. Now to find, let me draw the diagram of this circular section. And its neutral axis will pass along this line. Right here I'll have a centroid. Now let me find maximum shear stress first. Maximum shear stress is Q max is equals to 4 by 3 Q average. This is the formula, right? Now let us first find Q average will be equal to shear force by area, right? So how much is shear force given?
shear force is given 10 into 10 raised to power 3, and the area of this circle will be pi by 4 d square. And how much is the diameter of the circle given? 150 square. Now from here you find Q average equals to 0.566 Newton per mm square. Now you have found Q average. To find Q max, Q max will now be equal to 4 by 3 Q average, right? So from here I have 4 by 3 into 0.566. So from here you get 0.754 Newton per mm square. This is it. We have found Q average also, Q max also we found, right? Now we are asked to find shear stress distribution diagram. Yeah. So here maximum will come at this point, then it will reduce. So here you have Q max equals to 0.754 Newton per mm square, and the Q average will lie somewhere around this section. Here you have Q average equals to 0.566 Newton per mm square. So this is it for this numerical also. I hope it is clear.
This is the third numerical. A circular beam of section 200 mm in diameter is subjected to shear force of 100 kN. Calculate maximum shear stress developed in the section. Draw shear stress distribution across beam cross section. Okay. So again this is a numerical of a circular section, and जैसे हमने क्वेश्चन नंबर 1 and 2 पे सॉल्व किया था वैसे ये थर्ड पे भी वैसे ही सॉल्व करना पड़ेगा. Okay, so let us see how we can solve this numerical.
For this numerical again a circular section is given. So let us first write down given from the question. We have a circular section and the diameter of this circular section D is given equal to 200 mm. It is subjected to a shear force S equals to 100 kilonewton. So if you convert this into Newton, it will be 100 into 10 raised to power 3 Newton. Okay, then calculate maximum shear stress developed in this section. So we need to find maximum shear stress, which is Q max equals to question mark. Then we need to draw shear stress distribution diagram across the beam cross section. Okay, so let us start. Let me draw the diagram of a circle, right? And its neutral axis will pass from its midspan. Okay, the diameter of this circle is given equal to D is equal to 200 mm. Small d also. Now let us find the Q max, maximum shear stress. Q max will be equal to 4 by 3 Q average, right? This is the formula. Now how much is Q average? Q average will be equal to shear force divided by area of the circle. So how much is shear force given? Shear force is 100 into 10 raised to power 3 divided by area is pi by 4. Diameter of this circle is given 200 square, right? Now from here you get shear average shear stress equals to 3.183 Newton per mm square. Okay, now from here we need to find maximum shear stress. So how much will maximum shear stress be? Q max will be equal to 4 by 3 into 3.183. From here you get equal to 4.244 Newton per mm square. Okay, now let us draw the shear stress distribution diagram. Maximum will be here at this point, and then it will decrease and come here. So you have maximum at this point, Q max equals to 4.244 Newton per mm square, and this is a shear stress distribution diagram. I hope this numerical is also clear. These are very simple numericals.
Now, to find a maximum shear stress in a triangular section, you see a triangular section here. This is a triangular section. Now for a triangular section, to find the maximum shear stress, it will lie at a distance. ये अगर पूरा इसका ट्रायंगल का हाइट h है तो ये h को आधा पे डिवाइड करना पड़ेगा, which will be h/2 and h/2. So this line here, okay, so at this line you'll have a maximum shear stress, and for the triangular section the centroid will lie at a height h/3, right, from the base. So from the base उसका h/3 पे centroid lie होगा, so that line is a neutral axis line, and neutral axis line पे maximum नहीं आएंगे. So to find Q average, the formula is same. Q average is equals to S by A, and area for this triangular section will be half base into height. Okay, and if we want to find shear stress in this neutral axis line at height h/3 from the base, the formula will be 4 by 3 Q average. Okay, it will be 4 by 3. और ये neutral axis पे maximum नहीं आएंगे. Okay, maximum आएंगे h/2 distance पे from the base. Okay, so if you have to find maximum shear stress, the formula is same again, 1.5 Q average. So I hope this is clear. It is clearly written here that maximum shear stress occurs at a distance h/2 from the base. So from this base at h/2, जो ये यहाँ पर आधा divide किया है height of triangle से, वहाँ पर maximum stress आएंगे. Maximum stress ये neutral axis पे नहीं आएंगे in case of this triangular section. So let us solve the numerical. So this is a numerical for a triangular section, and let's see how we can find. The statement says a beam of triangular section has a base 90 mm and height 120 mm. If the section is subjected to a shear force of 20 kN, find Q max and sketch stress distribution diagram along the depth of the beam, indicating the values at controlling points. So let us see how we can find shear stress distribution diagram for this triangular section.
Now for this numerical, a triangular section is given, right? So a triangular section, let me draw the triangular section first. It is from the given. A triangular section is given, and the base of this triangular section is equal to 120 I'm sorry, not 120, it is 90 mm base, and the height of this triangle is 120. Height is 120 mm. Okay, now this section is subjected to a shear force S equals to 20 kilonewton, which will be 20 into 10 raised to power 3 Newton, right? Then we are asked to find Q max and then find maximum shear stress. Right, and sketch the shear stress distribution diagram along the depth of the beam, indicating all the values at controlling points. So we need to draw all the shear, indicate all the shear stresses after drawing the shear stress distribution diagram. Now how do we find Q max for triangular section? It is equal to Q max is equal to 1.5 times Q average. This formula doesn't change, it has remained same for all the three types of section. Now in Q average will be equal to shear force by area. Again, this formula is not changing. What is shear force given? Shear force given is 20 into 10 raised to power 3 divided by. Now what is the area of a triangle? Area of the triangle is half base into height. This is the area. So area will be half into base. Base is 90. 90 into height is 120. So you will have this. Now from here Q average will be equal to 3.7 Newton per mm square. Okay, now this Q max will be equal to 1.5 times the Q average, which is 3.7. so from here we get 5.55 Newton per mm square. So this is what we get. Now let us draw the shear stress distribution diagram. Now for this, where does the centroid for this triangular section lie? It lies at a height of h by 3, right? So at this height you have centroid G. And what is this height? It is at h by 3, right? And this Q maximum will lie at a half this distance. What is half this distance? If from here to here, if it is 60 mm, then from here to here I'm considering it to be 60 mm. So the maximum stress will lie at the middle portion, okay, of its height. So according to this, if I draw the shear stress distribution diagram, I'll get maximum will come at this point, which is this. Since this is the neutral axis line and this is the portion where I have divided the height according to the height, half its height, right? So I'll have maximum shear stress at half its height, maximum here, and then after that it will reduce. Okay, so here I have Q max. Q max will be equal to 5.55 Newton per mm square. Now if I want to find shear stress at this point, which is neutral axis point, so if I want to find shear stress in neutral axis, it will be equal to 4 by 3 into Q average. So here, how much will I get? 4 by 3 times Q average is 3.7. So from here you get equal to 4.93 Newton per mm square. So at this point, this is the point where you have Q neutral axis. Here you are getting 4.93 Newton per mm square, and this is a shear stress distribution diagram. Okay, so this is the last numerical, and I hope this numerical is clear, and I'll see you with more numerical in next session.